present research. So it does give me great pleasure to introduce our two experts tonight. It's a very important topic, a critical topic that we're looking at for fertility, and that is sperm health. So I'm going to introduce first Andreas Kortenkamp and then Sarah Martins de Silva, and then we will start with Andreas, and then Sarah will take over and do her presentation. But we will then take questions at the end. Okay, so if people can keep their microphones off until the end of the talk. So. Professor Andreas Kortenkamp is here from Brunel University, London. He is Professor of Human Toxicology and the Director of the Centre for Pollution Research and Policy, and was recently on BBC Two's Trust Me, I Am a Doctor with Dr. Michael Mosley discussing his recent research. He's an expert in pollution, especially in the combination of pollutants found in the environment. Our second speaker today is Dr. Sarah Martins de Silva, a clinical reader and consultant gynecologist from the University of Dundee and Nine Wells Hospital there. She is the clinical head for the NHS Tayside Fertility Services, the HFEA person responsible for Nine Wells Assisted Conception Unit, and runs the Scottish Sperm Studies Research Clinic. Sarah is also one of the BBC's most inspiring and influential 100 women of 2019. So thank you both very much for joining us today and giving us your talks. So we look forward to that. Thank you very much.
Okay, so I'd like to talk about combined exposure to chemicals, so-called endocrine disruptors, and their links or associations with deteriorations of semen quality. This is the picture that presents itself to us today. According to a very recent overview paper by Levin et al., the sperm concentration in men has declined. You see here on the left, the picture in roughly 1973, and to the right, as it is now. So we see a decline, according to this picture, which I've taken from their paper, by about 50% in terms of sperm concentration. There are definitely very bad trends in Europe. There are correct comparisons have been made. For example, in Scotland, I know of, in various parts of France and other parts of the world. We have here another measure of the decline in semen quality, which is total motile sperm. So this is, in fact, the most important parameter for fertilization success. This is the results of Fertility Center in Spain and in Canada. And you see here, let's focus only on the dark blue graph here, how the number of motile sperm has decreased over time in these fertility centers. A very large number of men are behind these data, more than 100,000. The question that has concerned us for a long time is what is behind this and what can we do, what are preventable causes? And from animal experiments and other models, we know that certain chemicals may play a role in this. This is highlighted perhaps by this graph, which I've taken from a paper by Richard Sharp, which shows how important the action of hormones is in development. So at around month 3 of pregnancy, there is the so-called male programming window. At this stage, male sex hormones have to be secreted and have to come in contact with tissues of the developing fetus to set up the development of the male reproductive tract. And if this doesn't happen or happens insufficiently, we then are likely to see irreversible damage for the rest of the life. So here is this window. And what the population group were particularly concerned about at this time are, of course, expectant mothers and the exposures they experience. If something goes wrong, the damage is irreversible. So, for example, the number of sperm a man can support for the rest of his life is determined by the number of sperm nourishing cells, so-called Sertoli cells, that are developing at this point in time. We know from chemical experiments that certain chemicals are able to disturb the development of the male reproductive tract in many ways. And this chart shows a series of, if you like, effector chains or key developments with example chemicals. So what is very important is, for example, the blocking of the receptor for the male sex hormone, or even the inhibition of enzymes that synthesize the hormone, down even here to painkillers, which have an effect on the local signaling of so-called prostaglandins in these tissues. So we use this scheme to make a list of chemicals that conceivably, if women are exposed to them at this critical period of time, might have a bad impact on semen quality. And our guiding principle has always been that understanding these bad effects on semen quality in men requires a mixtures perspective. It is hopeless from the start to make the attempt to explain this in terms of exposure to single chemicals. The approach we take is very familiar from single chemical risk assessment, in which assessors make ratios of the exposure of a chemical divided by what risk assessors think is acceptable. And you can imagine if this ratio exceeds 1, then chemical risk assessors and risk managers in authorities here in Britain and elsewhere get nervous and begin to think about measures to reduce the exposures of certain chemicals to prevent harm to the population. In mixtures risk assessment, we extend this principle by making a sum of all these so-called risk quotients, and we demand that in order to protect against such mixture effects, the sum of these risk quotients must also be lower than 1. The question then is, which chemicals should we consider together to make headway with a mixture risk assessment for semen quality declines? These chemicals, obviously, it's a matter of data availability. For these chemicals, we must know the exposures in human population, but also we have to have an idea about levels that are so-called acceptable where declines in semen quality no longer materialize. And here is such a list of chemicals. So we've undertaken a long review of the literature to assemble all the necessary data. What these chemicals are, these are dioxins, very toxic chemicals. They, for example, are generated during the incineration of wastes. PBDEs are brominated flame retardants. PCBs are very old chemicals in the environment. All these chemicals are in the environment and in all of our bodies. Acrylamide, then parabens, they're in cosmetics, and then some pesticides. And here we have plasticizer chemicals. Bisphenols, they are in tomato tins, leach out from epoxy resin, and painkillers, paracetamol. Now, it so happened that some collaborators of us in Denmark, Copenhagen, had data about the urinary levels of breakdown products of these chemicals highlighted here from one and the same individual. And this is an extremely precious data set which enabled us to make personalized mixture risk assessments. And in this little animation-like presentation that I will show you now, we will hopefully demonstrate some of these principles. This chart shows on the x-axis down here, the combined risks. They are derived from this addition of risk quotients I mentioned earlier. So the further right we move on this axis, the larger the excess exposure, excess combined exposure, relative to an index value of 1 here shown in the vertical line. So to the right of this, we're entering a zone where risk assessors normally with a single chemical would react with concern. On the y-axis here, we have a measure of the complexity of the mixtures concerned. And of importance is here, this line 2. This means that one single chemical constitutes 50% of the combined exposure. So this is quite dominant. As we go up here, this axis, the mixture becomes more complex. So let us consider the situation for one phthalate. One blob down here is one person. We have the chance of analyzing this for nearly 100 people. You see here the combined risk is very far. There is no combined risk because it's one phthalate, but we are well below this level of 1, which would signal concern. Now watch what happens as we add the second phthalate. The cloud of data points moves up. Obviously, the mixture has become more complex, but it cannot exceed the value of 2 because we're only dealing with 2 phthalates. Still no concern. A third phthalate, still no concern. There is no single individual entering the red zone. A fourth phthalate, you see the complexity of the mixture increases, but still no concern. A fifth. Now we're beginning to see roughly a third of the people entering the red zone. Please note also the spread, the variation from person to person in exposures. At this point, most risk assessors in the past have stopped. They only considered phthalates. And still, many risk assessors would rate the situation in terms of semen quality with phthalate. Okay, we're borderline concerned, but not much to worry about. Now, in the next few slides, you will see how wrong one can get if one limits this consideration to only a few chemicals. We add 1 bisphenol. This is stuff you would find in mustard, but also other. Here, at this point, 50% of the people are over the line. Another bisphenol, nearly everyone. And finally, bisphenols, all bisphenols, F, S, and A. As I said, they leach out of tomato tins. And the most important food item for us for uptake of bisphenol A is, in fact, milk and paracetamol. We now see that all the individuals are over the line in the red zone, and some individuals experience combined exposures 100-fold over what is considered to be acceptable. This kind of presentation, now here I've added all the other background chemicals. This is the picture that presents itself to us. This we regard as a minimum risk assessment. We were not able to include the effect of air pollution on semen quality. There's papers coming out that has an influence as well. Nor were we able to include perfluorinated chemicals. We regard the evidence for declines in semen quality from perfluorinated chemicals as not very strong. What these kind of analyses show us is what chemicals we might want to target in order to get a handle on reducing risks. So this chart, shows the distribution. It opens the lid on showing us the chemicals, according to our analysis, that contribute most to these cumulative risks. Down here, let's begin at the left. We have lots of chemicals, brominates, flame retardants, pesticides. They are there, but they hardly make an impact really. Here is the critical line 1, the red line, horizontal. And you see here the first phthalate poking its head above that line, then all the bisphenols, the dioxins, paracetamol, and finally bisphenol A. So this graph is really an important tool for risk managers. It shows us which chemicals we should reduce in terms of exposures in order to have a maximum effect on improving the situation. And obviously this would be bisphenol A, paracetamol, dioxins, and the rest of the bisphenols. A little word about bisphenol A. France has pronounced a ban of bisphenol A from all food contact materials. That, I think, is the right way to go. We need to look in Britain whether that's possible and whether we should do that. I would argue strongly we should. A word about paracetamol, that this may surprise many people. It was found that the painkiller paracetamol, when taken in this critical period male programming window, can have drastic effects on male reproductive health. Women who have taken the drug, there are epidemiological studies, their baby boys have a very elevated risk of non-descending testes. And from animal experiments, we also know that paracetamol can lead to declines in semen quality. So with these thoughts, hopefully this work we have done has the character of a prediction. It would be the next task in a well-designed human health study among men to see whether these predictions we have made actually hold water with real declines in semen quality. This work also shows us what the contours of the chemical problem behind this might be looking like and what could be done to improve the situation. So with these thoughts, if you want to read that more about it, here's the paper. And with these thoughts, I'd like to thank you